if you do that complicated. Finally, the book just talks briefly about criterion coding. I think more as a really, if you're really into this stuff, it's kind of an interesting way that there is a way you can code all those groups so that you have one variable that captures which group you're in. And that's what criterion coding is able to get. It gets it. It's a way of coding multiple groups into a single variable. The problem is, as they do point out in the book, your statistical output then is going to be wrong because it's going to be based on, the computer doesn't know. SPSS doesn't know, oh, treat this as a criterion coded variable that's really 4 groups. It's going to treat it as if it's a continuous variable. And all your test statistics are going to be based on the wrong degrees of freedom. So it's kind of a really clever sort of mathematical geeky thing, but you really don't see people use it. And generally, when you, I think Keith may make this point, but if not, I'll make this point. There's generally better ways of dealing with it. If you're in a situation where for some reason you may want to do criterion coding, there's generally better ways to deal with the data. So we're not even going to talk about it, other than I'm only bringing it up because he talked about it a little bit in the book. But the problem is, because it's going to give you the wrong degrees of freedom, you have to then end up recalculating things by hand, and you're more likely to screw up, I think, once you start trying to make categories into a continuous variable. Case in point, I knew someone, over the years I'm asked to kind of help with all sorts of statistical problems people are having. A good colleague, someone I knew, their student came to talk to me about some analyses they'd been running, and they were looking at race ethnicity, and they had 5 different ethnic groups. And I'm looking at they're kind of written up the results, and I'm looking at the results. And ethnicity, they reported ethnicity, the ethnicity effect, as the degrees of freedom was 1 and some, 280, whatever it was. And remember, kind of with this is one of the reasons we insist that you report degrees of freedom, because when you see degrees of freedom 1 and whatever for a categorical variable, how many groups are there? So it's the one, how many variables? The first is how many variables, right? So if the degrees of freedom for race, ethnicity is 1 and whatever, how many groups? How many variables do I have? How many dummy codes are there? 1 and say 280 degrees of freedom. There's just one dummy. There's one dummy code. That's what that 1 is, right? It's K. The first for F, the first 2 degrees of freedom is the number of variables. So if you see 1 and then the 280 is related to, it's not quite equal to, but it's related to how big the sample size is. So if it's 1 and something degrees of freedom, I know they've got 1 dummy code for 5 groups. It can't work. I mean, so I'm looking at this, and immediately I'm talking. No. I'm assuming you've made a typo. You've done a copy paste there, whatever. You can't do 5 groups with 1 dummy code or 1 whatever it is. Maybe it's effect code. Well, no. There's something wrong. So I said, go back, pull up your output. I'm sure you're going to find, when you take a look at it, that's got to be a 4 because there's 5 groups. It's got to be a 4. Next day, the student doesn't come back. Their advisor comes back with, I'm confused. Why does it have to be a 4? And so we kind of go through the conversation of, they were coding ethnicity. 1 is white, 2 is Hispanic, 3 is black, 4 is Asian, whatever. It was they treated it as a single continuous variable, and we're just plugging that into the analysis. Which, if you think, so Hispanics are double whites and being black is Hispanic plus white and Asian. Obviously it makes no sense. So that's part of it's another thing with criterion coding. It always just makes me cringe, the idea, because it just seems that you're asking for trouble. But again, code for any categorical variable, this is how you do it. You have to create however many groups you've got, those k, if it's k groups, k minus 1 dummy codes, effect codes, orthogonal codes, something. Dummy codes, again, is mostly what you'll see, and that's for our class, unless I tell you otherwise, and I will tell you otherwise sometimes, that this is effect, particularly like the next assignment, we'll get into it a little bit, of kind of making sure you can understand the difference between effect and dummy coding. Kind of how do you calculate what the averages are in that, because you will need to at some point, or even if you're just reading the literature, to keep track of, okay, they've done effect coding, how do you interpret their coefficients?
So they forgot multiple regression. The variables can be continuous. They think about that, they use one variable.
They use one
code all these the categorical.
Yeah. Because in SPS, if you do an ANOVA,
yes,
that you can tell the computer this is a categorical variable, and the computer recognizes, oh, because it's ANOVA, because ANOVA will only, unless it's the covariate, ANOVA will only, the predictors have to be categories. So it looks at, oh, how many different levels are there? Oh, there's 5 different levels, and I'm going to make 5 different groups. And so ANOVA does that all for you internally because it knows that's a categorical variable. But in SPSS, but with a regression, it doesn't know it's a categorical variable. Because as regression is that, ANOVA is that special case of regression. So regression is able to deal with it categorically or deal with it continuously. You just need to, and you can think of it, if it helps, you can kind of think of it, if you do ANOVA with that category, if they did an ANOVA with race, behind the scenes, the ANOVA is making those 4 dummy codes for it's saying, oh, here's your race variable, there's 5, it goes from 1 to 5, there's 5 values, so I'm going to make 4 dummy codes. And ANOVA is doing that all for you in the background and just cranks out the results. SPSS, because it's more general, it's not going to, it doesn't hold your hand as well, but it gives you the flexibility now that you can do categorical variables or continuous variables or both at the same time, which gets us to the next chapter, where we're going to look at both at the same time. This, what we've done so far looking at the categorical, you could do that in ANOVA, and that would be fine. But what happens if you also want to look at a continuous variable and the categorical variable at the same time? You can't do that in ANOVA. So that takes us to the next chapter.